Welcome to this AMable interview. My name is Antti Vaajoki. I work for VT Technical Research Center of Finland. And today we are here with the AMable participants working in an experiment abbreviated ADIESSN. And we have two members today with me. So basically, without further ado, could you please introduce yourselves? Who are you and what do you do?
Hi, my name is Siddharth, and I'm the Managing Director of Tiwari Scientific Instruments. We are a European Space Agency supported startup, and we are specializing in metals and ceramics. We have participated in this project together with NanoJoint to develop a 3D printing solution for NanoJoint's patented metal-based.
My name is Adrian. I'm the CTO of NanoJoint, and we are a Berlin-based SME. And we were founded in 2015, and we produce, develop, and sell interconnection materials.
Okay, thank you. So could you please describe your idea or product that you have developed in this experiment?
Yes, of course. So our idea was to combine our high-performance interconnection materials for 3D structures. So our pastes, which we have now already, can only be used for 2D structures, and therefore we saw a new approach for even 3D structures, but there a new method was needed. So we thought, okay, additive manufacturing can help us, and in the feasibility study we wanted to develop a silver containing filament applicable for the 3D printer of Tiwari.
Okay, thank you. What challenges did you expect in the beginning of the project, and what challenges did you actually have during the project?
Actually, when we started, of course, we made the proposal and we had identified some of the, let's say, riskier activities, or what are the main risks associated with this. And this was the main issue, was finding a suitable binder for this filament that we have in mind. Now, let me explain you why the binder is a problem. So when we talk about filaments right now that are available of metals and ceramics, they contain a thermoplastic binder. This could be, for example, polyamide, polypropylene, or some kind of polyethylene. Now, these can be thermally removed and are normally done this way. This is what we're doing. But in order to remove this completely from the metal or ceramic, we have to reach temperatures of more than 400, 500 degrees Celsius. Now, this was completely unacceptable for this experiment, as NanoJoint silver paste starts sintering at temperatures much lower than this, so 200, 250 degrees Celsius. So the biggest challenge was actually to find a binder that's suitable for this application. So a binder which helps us to print the complex objects that we want to do, and then which can be eliminated thermally at temperatures around 150 or lower than 200 degrees Celsius. And when you try to search for a suitable binder in this category, you are left with very little choices. And in addition to that, we also thought of choosing a binder which is green, so which is neither toxic and potentially could also be, let's say, recycled.
Okay, thank you. Which AMable services did you choose and why?
We chose the AMable service for materials for additive manufacturing. This was provided to us with VTT. The service helped us in eliminating potential candidates. So we really had to look at wide range of starches, cellulites, and kind of discussing it with the experts of VTT, we figured out what would and what would not work.
Then how has AMable helped you until now, or how have you benefited from the AMable support?
I think the biggest advantage with developing a new innovative idea is who is going to take the risk in helping you develop that. And by participating in this feasibility study, we bring something that we had in mind as a something that works theoretically. We could actually try it out in the lab and to see if our idea, which we came up with, works in reality. So this was one of the big advantages. It provides us the necessary resources, and resources, by resources I mean not just financial resources, but also, let's say, the technical support that we get from AMable to try out this idea. And it mitigates the risk associated with such, let's say, innovative but risky development.
Nice to hear. And regarding that one, when do you see that your product would be available on market?
So in the moment we plan a follow-up project. So the product is not really ready. We also have to do some more R&D work. And with the planned project, we hope we can have a first version of a product next year on the market. So in 2022.
Okay, that's really nice to hear. Regarding that one, do you perhaps have additional plans for other AM products as well, or what's the situation with that?
That's one of the challenges with 3D printing. You have so many possibilities and so many markets that you could potentially offer solutions to, but identifying one, let's say, use case, which you know is a killer application, is the key to moving ahead with 3D printing. And that's what perhaps we did in this project with NanoJoin. And now we actually also identified another very useful case for one of our ceramics to develop mirrors for satellites.
Let's hope they are successful, your other ideas as well.
Thank you.
How has your experience been like with AMable experiment?
Yeah, we made really good experiences with the AMable project. So the feasibility helped us a lot to understand more how we can plan the next R&D steps. And even the feasibility study was not completely successful. We really learned a lot, and we see a lot of points of contact for further R&D work. And we want to go there further and develop new products.
Okay, thank you very much for your time for this interview, and I wish you the best of luck in your further development of this product that you're dealing with in this experiment, and also some additional AM products that you envision as well. So thank you very much.
Thank you very much.
Thank you so much as well.